Artificial intelligence, or AI for short, is a subfield of computer science that's driving huge changes in business and in our daily lives. From smart gadgets to voice assistants to chatbots, AI is everywhere. And yes, students even use it to help with their classwork from time to time. But what is AI and how exactly does it work? That's what this video covers. Specifically, we'll look at three things. We'll define what AI is, explain how AI systems work with a focus on machine learning, and discuss a number of important terms in AI. First, what is AI? Lots of organizations, including Amazon, Google, NASA, have come up with their own definitions of AI. But we like the European Union Parliament's best. They define AI as, quote, the ability of a machine to imitate human capabilities, such as logical reasoning, learning, planning, and creativity, unquote. These tasks can include creating art and other types of content, making decisions, translating languages, managing customer service issues, filling out forms, giving recommendations, and more. But how does it do all that? Some AI systems are relatively easy to understand. They use programmed rules to process information and make choices. These are known as symbolic AI because the rules and data represent real things. A famous example of this was Deep Blue, the chess-playing computer that IBM developed that was able to beat Garry Kasparov, the chess grandmaster, in 1996. But others, including AI applications we frequently use, are not so easy to understand. Known as non-symbolic AI, these tools are fed instructions or prompts by users and then use complex sets of mathematical instructions, or algorithms, to recognize patterns in data and then predict what output the user will want. At a basic level, these AI models work similarly to the predictive text feature you see when writing a message on your phone. That system has been trained on large amounts of text data to recognize word patterns so that it can calculate probabilities for what word is most likely to follow a given word or phrase. For instance, it's likely that when you start a text message by typing happy, the system will suggest birthday as the next word. More advanced AI models like ChatGPT operate on the same core principle, but are trained on much larger data sets and can generate much more complex and contextually appropriate responses. And just like you get better at a task by practicing, AI's predictive abilities also improve by running their algorithms millions of times. This process, called machine learning, enables AI systems to improve their performance without constant human instruction. This is what makes them so powerful and versatile in solving complex problems. But the key takeaway here is that AI is not magic. Even though this process is called machine learning, it's important to remember that AI systems do not actually learn from, understand, or make meaning of data. They just analyze it using math. It's very sophisticated math, linear algebra and vector calculus, that uses massive data sets and huge computational power, but it's still just math. So how does machine learning work? Machine learning relies on neural networks to mimic the way the human brain, which is made up of billions of neurons, works. These networks are made up of layers of processing units called nodes, each of which analyzes a given feature in a complex pattern of data. As AI systems become more and more sophisticated, their neural networks are programmed to have more and more layers of data and mathematical processing. Machine learning systems with multiple layers in their neural net are using what is called deep learning. So, if you were designing a deep learning system to recognize dogs in images, you might program with one layer representing the lower jaw, a higher layer representing the nose and mouth, and a higher layer still representing the head. Yet, programming the layers is only the first step. In order for these nodes to be able to accurately analyze the data, the AI system needs to be trained. For example, in order to recognize dogs in pictures, the system must be given thousands, if not millions, of images labeled dogs and not dogs. In a training process, the system tries different parameters for each of the individual nodes in the neural network so that it can select the set of parameters that classify an image as a dog or not a dog with the highest success rate. This is known as minimizing the loss function. The training program just works and works until it finds the parameter set that generates the fewest errors in identifying dogs. Training, therefore, is a mathematical process of trying many, many node parameters until the best ones are found. This is, of course, a simplistic example, and most image recognition AI tools will have hundreds or even thousands of layers. And that's the real power of AI, the ability to crunch seemingly infinite amounts of data to identify patterns. Now, once an AI system has been trained, it can make predictions based on new data. In our dog recognition example, the AI system would use the neural network parameters from its training dataset to predict whether new images that it has never seen before are or aren't dogs. It's important to note that the system has no idea what a dog is or what a dog isn't. It just uses math to make a probabilistic estimate of whether or not a new image contains a dog, using the set of parameters it selected during its training. Then, lastly, the system's performance should be assessed over time in order to improve and retrain it. So, now that we know basically how AI works in terms of machine learning, let's look at some other terms and definitions that are important to know. Everything we've talked about so far refers to a type of AI called weak AI. Also known as narrow AI, a weak AI system is designed and trained to perform a specific task, such as recognizing dogs in images. It operates under a limited, predefined set of conditions and doesn't have the broad range of capabilities that humans have. Large language models, known as LLMs, are a class of weak AI models. They're trained on enormous amounts of data to write language in response to prompts or requests from users. LLMs have the ability to generate coherent and contextually relevant responses, translate languages, summarize text, answer questions, and even engage in creative writing. ChatGPT was a groundbreaking example of an LLM that got wide usage. Natural language processing, or NLP, is a key function that LLMs use. It helps computers analyze and generate human language so that they can listen, read, and talk more or less like humans do. It's how we interact with virtual assistants like Siri or Alexa. Predictive AI blends statistical analysis with machine learning algorithms to find data patterns and forecast future outcomes. It analyzes historical data to make predictions about the most likely outcomes for an upcoming event, result, or trend. Predictive AI models can help project sales, estimate product demand, personalize computer experiences, and optimize logistics. They're now commonly used in investment management too. Generative AI, also called Gen AI, are models that respond to a user's prompt or request by generating original content, such as audio, images, software code, text, or video. Gen AI uses machine learning to incrementally predict many units of content simultaneously to generate complex output, such as a paragraph or an image. ChatGPT and Canva are examples of Gen AI models. In contrast to weak AI, strong AI is a hypothetical type of artificial intelligence that would possess a consciousness and general intelligence so that machines could think, reason, and make decisions like humans. Artificial general intelligence and artificial superintelligence, which are other terms you may have heard, fall under this category too. Humanoid robots, like in the Terminator movies, are good examples of how science fiction portrays strong AI. But it's still science fiction, and there are big debates about when or even if we'll ever have, or should have, strong AI. Knowing the difference between weak and strong AI highlights the point we made earlier that AI is not, nor is it likely to ever be, intelligent. Even though the outputs of AI often seem human-like, AI doesn't understand things the way humans do. All they do is math. To summarize, AI systems are mathematical models that consist of computer algorithms running on large data sets. Machine learning, the most common and powerful form of AI today, analyzes data, classifies it relative to its trained dating set, and then predicts output on the basis of that analysis. Although this output appears responsive to requests made by the humans who use these systems, AI apps don't know what the user wants or what the best output might be. They merely predict that output based on the underlying algorithms and training data. We've just touched the surface of what AI is, the various components that make up AI models, and the different types of AI tools. If you're interested in learning more about how AI works, we strongly suggest you take an AI course and engage in deeper study. Now, armed with this basic understanding of what AI is and what it does, let's take a look at what some good uses for AI are. That's in the next video.